So I am James Kahkoska. I call myself the reluctant CTO because I sort of fell into this role. I'm going to step back a little bit. This is my first Wireless LAN Professionals Conference, and I'm just been taken aback by the spirit and the vibe. It's a wonderful thing. You know, if you Google maturity model, you see that in almost any industry or any space that there's this notion of a maturity model. And you know, the first time I saw this was when I was doing software in the 80s. It was the software maturity model. And it's basically how do you get from go-to statements all the way up to structured programming. But it's basically about a journey of self-improvement and how you move up that curve. There's also maturity models for community. So when I think about this community, you know, it just feels like it's all pretty far to this side. You know, this is amazing. I mean, the cooperation, the collaboration, the sharing of information, sort of the selflessness of the environment, I think has really been amazing to me. And as a tool vendor, you know, we're down here somewhere. We're trying to move the same direction as this community is. We're trying to become more integrated. So when I saw Keith put this information up, I was like, wow, that is exactly the example of maturity, right? We're getting more of a process focus, more of a common language, how we speak about problems, how we approach problems. And it sort of struck me that, well, there's actually you know, for all these as he spoke to, this is just a dot, but there's this whole, you know, where there's state machines or bounce charts or stacks running up on top of all of this, that it's all quite more complicated in this diagram, but it does, you know, it's a place to start, and it's a place to start breaking down the problem. The other thing that's always amazed me about networking, and I don't think enough credit is given for this, is you know, and sort of joke about the ISO stack, but the reality is the ability to swap layers is quite phenomenal, and especially over the period of time that networking has existed. So. You know, because you don't see that. It's always easy to invent new things and break the past, right? If you can start over, there's nothing like that fresh new greenfield. You probably know that from Wi-Fi, but so I actually drug out the other day one of the products I worked on back in '95 and plugged it into my 10 gig switch, and lo and behold, it linked and actually picked up packets and stations, even though, you know, 20 years has gone by. Actually, 25 years has gone by. So, in fact, the hardest part of this whole exercise was finding the old wall wart that would power the thing, of course, because the battery was crapped out. But pretty amazing. Of course, I didn't find any IPX stations because that's moved on. But you know, this is, like I said, this is really the amazing part to me of Ethernet and Wi-Fi, is that you can get an old B client and run it on a new AXAP. You can get an old wired client and run it on the latest, newest 10 gig wireline switch. So. You know, and a lot of this is as we go through time, the amount of information that's being packed into a time slice. So I'm actually more of a wireline guy, learning a lot about Wi-Fi these days, but you know, on the Wi-Fi side, it's modulation, and it's been largely about the, you know, in a given chunk of time, how much coding can you get, how many bits can you cram into that little time slice. Well, it turns out the same thing has been going on, hopefully unbeknownst to you, or maybe unbeknownst to you, on the wired side, right? Only it's been line coding there. So back in 100 base T, it was a very binary thing. You got a 1 or a 0, and then they started to get into breaking up this voltage swing on the wires into a couple layers. Now they could cram a couple of bits into any time slice, and as we get to 10G base T, basically you're down to these little 133 millivolt increments for each bit of resolution. And a lot of this, just like in Wi-Fi, has fallen upon the digital signal processing to pull the signal from the noise. So this sort of leads into Shannons Theorem. So Shannon actually is compared to Einstein and Newton, doesn't get nearly the acclaim, but he was sort of the father of modern information. And and math has never quite been my strong point, but basically what it says is if you have a perfect transmission media, it's going to be degraded by the amount of noise. So, and it is all about noise. So so if you think about it in practice, a couple things here. Here's from MIST, one of their presentations, that when you're doing 1024 QAM coding, the green area, it's a shorter distance, right? So in Wi-Fi, you're mobile, you're moving around, there's a distance between you and the AP, and the coding will be a function of that distance and the noise and what it can get away with. Well, it turns out on the wired side, there's something called auto downshift. And so most PHYs, as you're beginning to deploy AX and looking to 2.5G, NBase T, 2.5 gig, maybe even 5 gig link speeds, it's largely going to be that as the noise level goes up on the wire, that the speed's going to downshift. And the PHYs actually downshift for you automatically in general. It's programmatic. That's kind of the noisy details at the bottom here, but by and large, that's going to happen. So I've always been, kind of fascinated about this whole NBase T and PoE thing because we're really using the cabling in a manner in which it was never intended. So when you think about the huge, blowout of Ethernet and wireline technology through the late 90s and through the 2000s and dot bomb and such, that was all Cat5e cabling that was installed. And so right now, 90% of the installed wire in the world is Cat5e. And it's kind of like your home modem, right? When they pulled the telephone line to your house, they never thought you'd be running DSL at tens of megabits, but it's come down to modulation, digital signal processing to pull that out. And NBase T is not just about APs. I just saw this announcement. The new i9 core has a 2.5 gig MAC built in, and so it'll be very easy in any future wireline device to have 2.5 because because it's just built in the processor, just like 1 gig Macs are built into processors now. So we have this thing in our lab. We call it the cable coffin. We built it back in like 2004, and it's even got some silver satin in there. But down here in this section, it's just different lengths, right? And basically, it allows me to immediately get to any length of cable by patching together. And you can cascade things. I can cascade a 200 into a 20 foot to get 220 feet plus the patch, and sort of run some experimentation on NBase T over Cat5e and kind of see what happens. So at 100 feet, everything was quite good. We advertised, and this is our little lingo here of what's advertised and what's actual. So the actually I got that backwards. The actual is bold. The advertised is gray. As I got to 210 feet, kind of building up these things, all of a sudden, the actual link speed dropped to 2.5 gig, right? I got far enough distance, there was enough noise, enough attenuation that there was something going on there. What was really amazing to me was the time to link. Keith talked about the link LED kind of being your best friend or the equivalent of association this morning. The time, normally it takes 3 to 5 seconds to get that link light to go on a wireline connection. In this case, it took 22 seconds. And it was because the DSP kept trying, try 5 gig, and it is a little bit programmatic, and it'll vary from device to device. But generally, you're going to see that they try the highest speed they can, because that's based on the link advertisement, which is a very slow pulse. It's like a basic rate equivalent. And then they will the DSP will sit there, do its thing, right, and then say, hey, I'm going to downshift. But that takes time. So as you're deploying gear, probably one of the simplest things you can do without test equipment, which is probably something a test equipment vendor should never tell you, is you can always take your AP, plug it in with a short patch cable right at the switch, just get a sense of how long it takes for that thing to link on that switch. Then go out to the point of deployment, plug it in, and then kind of watch. And if you see that it's taking more time than you think, there's a fair chance that it was struggling to get that link to come up, to negotiate reasonably at that speed. Now, what I will say is once that link is up, it will basically run at that rate. In other words, the negotiation is more rigorous than the data transmission. And I've had numerous PHY vendors tell me that over time. So the next thing to look out for in NBase T is impulse noise. This one actually we backed into about 4 or 5 months ago when we were preparing the new product. We run these 24-hour 10 gigabit line rate performance tests, and we were running over Cat6 cable, Cat7 cable, and they're very deterministic. It's literally every frame sequence numbered, accounted for, FPGAs on both sides doing all this. And we were just seeing these crazy spikes of loss, and it drove us crazy for a couple of weeks, and couldn't quite figure it out. We assumed it was something in our hardware. Is it when you're on an AC adapter? Is it the AC power phase? Is it, we kind of went through all these things we had seen in the past. Turns out, lo and behold, that 2.5 gig and 5 gig is wire speeds, especially above 1 gig, are fairly susceptible to impulse noise. And if you go out and look, you'll see that there's all kinds of stuff. So if you have the coveted Aeron chair, maybe in the middle, that's actually probably one of the bigger static generators. And in fact, just a bunch of experiments where literally even even 10, 20 feet away from where this chair rubbed, they would see it on the wireline side. So keep an eye out for impulse noise off of static and chairs. Once we became aware of that, we're like, well, we can emulate this. So we go back into the lab again. This is an ESD gun here on the lower left of the picture, and we can set it up to any charge level we want and discharge it on that piece of metal. And sure enough, we'd run our line rate performance test, and we could get this thing, every time we sparked it, we'd see frame loss on the wire. What kind of surprised us was, and quite happenstantially, was there was actually an air conditioner up above this table. And a couple times we saw the loss when we didn't spark it, and we're like, what the heck? Turns out it was that air conditioner turning on and off periodically, so you can get motor impulse. So as you're deploying your new fancy access points, keep an eye out for impulse noise if you're seeing any loss. Alien crosstalk. This Keith also alluded to, which is basically the things you need to worry about are the co-conspirators in your technology domain, was I think how I thought of that. And so in this case, it's cables in a bundle. And if you look at NBase T, given that you're probably deploying it on Cat5e, because in general it's going to cost you as much to pull a new cable as it's going to cost for that access point, right? So you're going to want to run it over the cable plant you have. And if you look at it, it's actually the amount of time that the cable spends in the bundle that starts to affect what type of cabling you can run on. So be aware of that. I actually had these grandiose plans about a week or two ago that I was going to do more on sort of noise and crosstalk, and I wrapped some cable around the ballast of a fluorescent light, and I got into I was looking at the data sheet, and I can read the signal to noise out on all 4 channels, which is the 4 pairs, and was playing around with reading the signal to noise. It was hex. I need to get the factory test guy to put in a little more a little better macro command for me here, but hopefully that'll be a topic in the future, but something I want to continue to pursue. So the takeaways are: keep an eye on the link time, impulse noise matters, the length of the cable matters. As you can see at 2.5 at 2100. 210 feet, I was already downshifting, and then the length in the bundle matters. So that's something to keep in mind there. So the other way that the number in the bundle will affect the amount of noise and crosstalk too. And I would imagine even the speeds of the cables in the bundle would probably affect. So I'm going to try to do more characterization on that going forward. Another thing that when this cabling went in, chances are PoE barely existed, or it was providing, 6 watts to a phone, right? Because Cisco kind of started the PoE revolution. Well, now, we're basically sourcing 90 watts, right? And so 71 watts is available at the PD, the powered device at the end. So kind of went after this one too with the cable length, the cable coffin. And but I wanted to take the switch out of the equation. So this is actually an eval board from one of our PoE vendors, and I used a rugged power supply, right? So there would be no sag in the voltage or current, and started to play around delivering PoE over all 4 pairs. So at 10 feet. The other thing I should say is in our products we have the equivalent of a light bulb. So we measure the voltage, we plug the light bulb in, then we measure the voltage again, and that's the voltage under load, right? It's kind of like starting your car on a cold morning. The battery can read the voltage, but go to turn it over, voltage drops. So it turns out at 10 feet things were pretty good. I was losing 1 volt. At 100 feet, I was dropping about 3 volts, loading at 70 watts. At 210 feet, this is the point where I downshifted, if you remember, to 2.5 gig. And it took 22 seconds to link. I was dropping about 5 volts, and at 350 feet, I was dropping about 8.3 volts. So kind of where I landed on this one was that the voltage drop isn't too bad, right? In fact, even though as they've moved to higher power, they've brought the threshold up. It used to be 39 volts was the minimum. Now it's about 43 volts. And so I still had some pretty good margin there. And 350 feet is more than 100 meters, which is the spec for wireline Ethernet. PoE, what I've run into more is just the vendor inconsistencies. There was all the different classes. There's Cisco always did these one-offs to kind of break the ground, and like with UPoE and things like that. There's linear tech PoE. There's just all sorts. There's variance there for sure. All right, so I'm going to shift away a little bit from the wireline and pull back into the bigger map, and so kind of took a piece of the overall thing here, and talk about firewalls, right? In firewalls, it's about what ports are open in general and all that. And I think it's kind of fascinating, as wireless LAN professionals, so we moved to more cloud-based wireless LAN controllers. Firewalls will become more of a factor because the WLC is not on-prem. And so I went to look at the rules, in this case on Meraki, and wow, it's pretty extensive. That thing uses a bunch of ports, right? And there's a chance that those ports may not be open in the environment you're in. So anyway, I found this cool little website, if you want to know if a port's open on a firewall, where it basically responds, does a TCP Synack on any port from 0 to 65K. And there's ways you can certainly do it on the command line. I, in my case, chose to define a particular TCP Connect test for each of the port types, so that with basically a one-button auto test, I can go in and validate all the ports are open. So kind of a nice website for you to, and we'll have the slides, but this is fairly handy for doing quick what ports are open on firewalls. Keith talked about this a little bit. In my particular case, I had the opposite of the problem. But is it when you're trying to parse the problem out? Is it wired? Is it Wi-Fi? What's going on here? That in this particular case, SNMP, and we had the talk yesterday a little bit on SNMP. That SNMP monitoring lets you basically understand the utilization of any of the ports anywhere in your infrastructure. So in this particular case, I was running a speed test. It was slow. I was like, what's going on? By having SNMP access to the gateway, to the router, to the interface to the WAN, was able to see, oh no, there's actually, you can see the 2 bumps. One is the upstream, one's the downstream on that interface. And so immediately I was like, okay, this isn't a WAN problem. In fact, given that I was hitting 12% at 12 megabits, I was basically on a 100 meg pipe. So you can even get a sense watching SNMP of what the capacity is of those links as a percentage of utilization as you run something like a speed test. So getting an SNMP tool in your life is typically a good way to keep an eye on the infrastructure. DHCP is pretty fascinating. One thing I notice a lot is the time to get the first DHCP response is quite long. In this case, it took me 14 seconds. And it was, DHCP is, DORA is the acronym, right? Discover, the client sends a discover broadcast. Discover, offer, DHCP server offers, request, client requests that specific IP, yes, I want it. Accept, the client accepts it, so or the server says yes, you can have it. But basically, DHCP servers cache your MAC address, a little bit like the 24-hour captive portal here. And so the second time you come in for a DHCP response, you'll see it quite fast. So in this case, exact same server ran the test again a few seconds later, and immediately I was into a 1 millisecond, basically a real-time response. But kind of watching how long it takes the DHCP address, you'll know, am I within the lease period? Did it expire? And sometimes it even speaks to the flatness of the network, and the robustness of the DHCP server in terms of making sure that isn't a dupe that it's handing out or things like that before it hands it out. So kind of like watching the time that it took to get link, watching the time that it takes to get DHCP can give you some insights into your infrastructure. My favorite case, and I've run into a lot of customers that have this. We've even had this happen, of course, in our house, in our building, in our office, is the infamous thing where somebody brings in a DHCP server, didn't realize something was acting as a DHCP server, plugged into the network. All of a sudden, everybody's getting doled out these 192, 168 addresses, and nothing works, and there they are sticking at that. And so one thing we've particularly done to try to combat that is watching for a second offer. So when we send out the discover, we try to watch for the second offer, and then actually show you that, and you'd even be able to do a path analysis to this first guy and figure out where he's plugged in. What employee plugged something in their cubicle they shouldn't have, that's now basically taken out the entire network. So that's a good thing to keep your eye out for. But if anybody's having issues and you're trying to figure out if it's DHCP, take a look at the IP address. If you see a 192.168, that's typically not going to be an enterprise address and be a pretty good clue that somebody plugged something in. The last one, and this is actually from the hotel right here, speaking to sort of the captive portal thing, is I have never seen lease times that short. Basically, and I think it's just because they're trying to manage the pool, and so the minute you walk away, within 10 minutes, that address is freed up for somebody else. And so keep an eye on your lease times too, and typically you can see that on the command line in your laptops and such, but I was kind of surprised. So here I was, I'd gotten the address at 6:13, and by 6:21, I was basically going to be, if I wasn't online at that moment, I lost that IP address, and then I'd have to go all the way back to almost the association, if you will, the reestablishment of that and the longer time. So something about DHCP there. Switch a little bit to, when I think about Keith's big picture, a lot of times many of these bubbles interact with one another, right? And so on an untagged port, a trunk port, which means the client has to put the VLAN shim in the packet, but there's an association through the entire network of VLANs to SSIDs, right? And even prioritizations. And so because you don't want your production network, that SSID will run on its own segmented VLAN and will will have a higher prioritization. I mean, you don't want some guy on the guest Wi-Fi, streaming or running a bunch of speed tests, and then basically hitting a point of contention in your network, like your router, and suddenly having frame loss there, right? So there's and you look at the infrastructure vendors, and there's basically a mapping all the way from what SSID I'm on, and then through the switches what VLAN prioritization I'm on, and then as it hits the router, the gateway, then it tends to go to DHCP, diffserv, and things like that. There's sort of a SSID to layer 2 VLAN priority to layer 3 prioritization that happens. So something to keep in mind there. So so as I think about this maturity thing, not only is it in this community and Wi-Fi in general, but I think if you look at a lot of the maturity models, as you go up, the more mature you are, and moving above ad hoc, it typically means kicking over silos and having more integration, having a broader view of the entire system, which is exactly what's happening here, right? I think I'll guess that in previous sessions it's largely been about the red box, right? The Wi-Fi side, and so here, we're moving a little bit more into the blue. It's been mapped and charted here, and we'll continue to explore in that space. And so on the tool vendors, and I'll speak about this agnostically, we're all trying to mature also, right? And so if you think about our particular line, we're trying to do more integration. If you think about what you can do with 2 Wi-Fi radios in a product, right? Up until a year or two ago, you only had 1 radio in any given test product. Right? Well, with 2 radios, in some cases, you're using it for scanning both bands at the same time, so that your survey has higher granularity as you're walking. You're basically getting those complete scan cycles every 2.5 seconds instead of every 5 seconds. Integration includes adding spectrum analysis. Some vendors are working that way. In my case, I'm tending to work more across the x-axis here, and 2 radios to me means that I can link and scan at the same time. And so this has been a particular area of fascination for me, because while you're scanning, you're picking up things in the air, but once you're linked, you can kind of start ARP sweeping and doing discovery on the connected network and get into IP addresses. And so, and all sorts of things start to open there. So I saw this, Troy posted this, I think maybe Sunday or Saturday, I think it was, but it's very true. I feel like client stations are the new battleground, right? The infrastructure, no matter what you're doing, you have some control over that, your APs, all the things we've heard about in the last 24 hours, but the real cats are going to be the stations going forward and the antics there. And so as we try to mature a lot of this on the tool side, giving you the best possible view into your networks is about visibility. And so specifically, and since I used Wes's AX coverage heat map earlier, I'll pick on him again. But as a vendor, any publicity is good publicity. We've been trying to move up the stack. And so basically, when I look at something from the Wi-Fi, from the client perspective, rather than seeing it as a bunch of MAC addresses and not knowing what it is, getting to best names. And there's a bunch of ways that devices put their names onto the network. And so as we're scanning through, we're seeing the RF, we understand the channels, the BSSIDs, the APs, the associations there. At the same time, we can be coming at it from the top end with the linked radio, ARP sweeping through, kind of a simplification, but doing a bunch of discovery to pull out SNMP names, MDNS names, which is basically the way Apple advertises things. That's, in fact, Wes is an Apple here, so that's how I got his name. NetBIOS, kind of the Windows laptop world, things like that. And once you can understand, once we know more than a MAC address in the tool space, there's a bunch of, and you get to an IP address, there's a bunch of things you can do. We can understand what it is. You can launch your browser against it. You can ping it to coax it out into the RF if it's an IoT device, things like that. So that is it. 1 minute to spare, and I guess we'll end it there. Yeah.